Well, good afternoon. We are working with linear inequalities today. And I know that we haven't talked about inequalities yet, so this will be kind of new to you. We are going to be doing this, however, with two-step equations, which is something that we have worked with. We just did that in the last lesson. So what I want you to do is go ahead and hit pause and copy this information down first, and we'll talk about it. Okay, linear inequalities are talking about less than, greater than, less than or equal to, and then greater than or equal to. So give you a little bit of insight before you get started and give you a little better understanding of what we're talking about. So go ahead and do this, copy it down and hit pause, and we'll start in from there. Well, as I said, less than, that and greater than is not anything new to you. But the less than or equal to, that is something different, as well as the greater than or equal to signs. And they say exactly what they're saying, what they are asking or telling you, whether that it is less than or it's also equal to. So if we're saying that it is that x is less than or equal to 3, then when we look at it on a number line, okay, then we can graph it according to that. And x saying that it is less than 3, here's 0, here is 3. If it is less than or equal to, okay, then it is going to include the 3, and it is less than that number. So I'll draw my line pointing this direction. So it is all of the numbers starting from that point, including the 3, and going to the left on that number line. That is what it's referring to. So it includes all the negative numbers, including 1, 2, and 3, and the 0. That was what that solution is telling us. Now, if we wanted to go about this a little differently, and again, I'm showing you on a graph just to have a little better understanding. If it were just the equals or the less than sign, and it were x is less than 3, then it would not, and we leave that as an open circle with a line going in that direction, meaning less than. But the open circle means that it does not include the 3. It is everything up to that point, or I should say less than 3 on down. Okay, that is how inequalities work, and we will talk more about that as well in future lessons too. So let's go ahead and get started, and I'm going to erase this part first, and I want to show you that when we solve inequalities, it says follow the same rules as solving equations, except when you multiply or divide by a negative number, the inequalities will be reversed. Okay, so let's look at this one, and when I solve this, again, back up to here, it is only when you multiply or divide. So we can't do it, it's only when we have those situations, which neither one of these will. I'll show you on the next slide. So the first part I want to show you is that it is virtually the same thing as solving an equation. The only thing that's different is instead of equal signs, it's going to be an inequality. Less than, greater than, less than or equal to, or greater than or equal to. Okay, so we first start with our number that's with the variable that's all by itself, and since this is a positive 24, we're going to add a negative 24 to both sides. And we draw our line. This equals 0, so we can leave it. So now it is 2w equals, and then since we are adding a positive with a negative, we subtract, and we get a positive 10. Now we're going to divide, because we have to get rid of our 2, so we divide it by 2 to both sides. and we get 1, a positive 1. And again, if this were a negative 2, then we'd have to divide by negative 2 to both sides. Okay, so we get W by itself, and 10 divided by 2 is 5. So W equals 5, and you can always check that by plugging this in, and 2 times 5 equals 10, and 10 plus 24 does equal 34. Now let's look at this inequality. Solving it the same way, negative 24 to both sides, and that gives us 0, so bring down the 2W, and our inequality, which is less than, and we get 10. Now we divide both sides by 2, and W says it is less than 5. Okay, so again, W, the answer is less than 5, so we plug this back in, and we get, let's see here, 5, oops, it's not working for me, and we get 34. Sorry, this should be an equal to. I knew that something wasn't matching up with it, my bad. So we get a 5, and this would then be 2 times 5, which equals, why my board's acting up, sorry about that, is 10. And so 34 plus 10 is 34. And does 34, is it less than or equal to 34? Yes, it is. Okay, the equal sign, less than or equal to, is very important, and I forgot to put that one in there. So do be very careful with bringing down your signs. My apologies for not having that set up from the very beginning. It should have been equal to begin with. So there you have it. But bring these signs down as they are, as they're listed here. Okay. The only time that this would be an issue, that we would flip this sign, is when we multiply or divide by a negative number. So if this number happened to be a negative 2, then when we would divide by negative 2, this sign would have to flip. Okay? So let's look at this next problem, and this is where we'll have that situation. So we have negative 3x is greater than or equal to 12. Okay, so since we are going to solve this problem, this is just a one-step problem. It is multiplication, so we do the inverse, which is dividing by itself, which is negative 3 to both sides. So when you do that, you bring down my x, which negative 3 divided by negative 3 is a positive 1. That's why we get 1 times x is x. But this sign has to be flipped. So it is not going to be greater than, it will be less than or equal to, and then you solve this. 12 divided by a negative 3, which is going to be negative 4. Unlike signs, will be negative. Okay? So my answer is negative, and this sign does get flipped. Okay? It's reversed. So instead of greater than or equal to, it is less than or equal to. It's only when you are dividing or multiplying by a negative number. If this were positive, the sign would not have reversed it, it stayed the same. So let's look at this next one. And I want you to go ahead and hit pause and solve this from here. This does again mean y divided by negative 5. So go ahead and do that. So since we have y divided by a negative 5, again, the first thing we have to do is start with our number that's by itself. So let's start there. So we're going to, since it says adding 3, we're going to subtract 3 or add a negative 3 to both sides. And we draw our line, and it is now y over negative 5. And that is a greater than sign, and then negative 7 plus a negative 3 is going to give me a positive 10. Okay, same signs are positive. Okay, And you don't have to put that positive sign on there. You can get rid of that if that helps you. So now, since this is a division problem, we have to do the inverse, which is multiply by itself. So negative 5 to both sides. And since we are multiplying by negative 5, okay, since it is a negative 5 that you're multiplying by, with this sign has to be reversed. So it is going to give me y, and this is greater than, so now it is less than, and 10 times a negative 5 is going to give me negative 50. Okay? Now some of you might be saying, well, I don't understand. How can you get this? This would give me 25. Remember, we're putting a line over it, over 1. Okay? And you can cross-reduce. Negative 5s and negative 5, they go into each other once. So that's why these both become 1s. Okay? And that's why they're positive 1s. Okay? So do remember that. That's your fraction rules that we've used, and I know you've used in the past. And we will continue to use them and talk about them further in the future as well. So some of this is why I'm telling you this again, just to get that clarified in your mind. Remember, you put it over 1, and then you can cross-reduce those fractions to where they both become 1s, because you're dividing them both by a negative 5, which gives you positive 1s. Okay? So that's how we get y by itself. This then, again, we had to reverse because you're dividing or multiplying, either way, dividing or multiplying by a negative number to both sides. It's only when you do it to both sides that you have to flip this sign. Okay? And so you can plug it in. It says y is less than negative 50, so you can pick any number that you want that has to be less than 50, and you can plug that in. So let's say negative 55. Okay, and a negative 55 divided by a negative 5 is going to give me an 11. Okay, goes into it 11 times. And so 11 plus 3 equals 14. And is 14 greater than negative 7? Yes, it is. Okay, so that's checking your solution. I want you to go ahead and solve this. So go ahead and hit pause and solve. Okay, so let's look at this. And again, we have a positive 8 here, so we're going to add a negative 8 to both sides. So then we get negative 4a is less than or equal to, and then 24 minus 8 is going to give me 16. And some of you, again, looking at this might say, well, that's a positive 4. Well, true, that is, but we're subtracting 4, which again, if we want to change this to addition, opposite of the second number, it is meaning the same thing. If you're subtracting 4 or adding a negative 4, it means the same thing. So it is a negative 4a, and so we are going to now divide both sides by negative 4, and therefore a we're bringing down, and since we divided by a negative number, this sign has to be reversed. So instead of less than, it is going to be greater than or equal to, and then unlike signs is negative, so we get negative 4 for an answer. And once again, if you want to plug it in, it says a is greater than or equal to a negative 4. So pick easy numbers, something that's greater than negative 4. So let's try 0. If you plug 0 in here, 0 times any number is 0. So negative 4 or subtracting 4 times 0 is 0. So we're going to simply get 8 is less than or equal to 24, and that is true. Okay, so some of you are saying, well, this right here is not the same as what this is saying. Do we need to switch this one in the answer, or in the original equation? No, you don't. You can see if we didn't flip this when we multiply or divide by a negative number, it would give us a number that's completely wrong. It would say that is a number less than -4, which would not make this true. Okay, so checking your answer certainly gives proof as to why we need to change this sign when we multiply or divide by a negative only number. Okay. If you have questions, this is a little more difficult material, so if you do have questions, please write it down, and we can discuss it further tomorrow in class, and hopefully doing a few more problems as well in the assignment will give you some more clarification as well. So please speak up, ask those questions. That's the only way we're going to learn this material. You'll continue to see this throughout the course of the year as well. And we'll use it in different applications too. So have a great evening. Bring your notes and questions, and we'll continue with this tomorrow. Have a great night.